So today we are going to cover nomenclature in Prometheus, and this is super useful because sometimes we use terms that may not make sense or it is ambiguous. So let's dive in. So first thing is metric name. Metric name, also known as metric. This is basically what we refer to when we send data. For example, HTTP request total. This is a metric name, right? You send this metric and you send a value to it. You also send attributes to a metric, and that's basically a metric label or label. So here is a good example. So you have a metric name, and then you have a few labels associated with it. And when you query in PromQL, this is the format you use. You use a metric name, then use curly braces, and then label name equal to symbol and the label value and a comma. So this is basically how a metric name and metric label are used in PromQL. Now, there is a third item which basically puts metric name and metric label together, and that's called time series. And time series is basically the unit that is used in Prometheus, since Prometheus is a time series database. So everything that you store in Prometheus is stored as a series or time series. Simply we call it series. Now let's take a look. Like, I am right now using Prometheus API, and I'm using promtool. So I'm gonna use promtool. Promtool is a tool that could be installed, command line tool that could be installed if you install Prometheus. What I did was I did brew install Prometheus, and this got me promtool. Now promtool can connect to a remote Prometheus server. It just so happens that I have Prometheus server running on Docker here. So I have Prometheus running here at port 9090, localhost 9090. So I'm going to connect to that. So now let's look into a series using promtool. So let's run this query. So promtool query series, and we are connecting to this server that is running on Docker. And we're gonna pass a match parameter, and we're gonna pass the metric name, and let's see what comes up. So here we see three distinct series, and they're different because the instance name is different for each series. The first series belongs to instance app1, second belongs to app2, and third belongs to app3. And if you remember from a previous video, we have three fast API web servers running, and they have different instance names. We could also have different job names if we have fast API plus some other web server or some other background worker. We can also have different method names. Right now we only have HTTP get, but it could be put, post, delete, anything. Now we have a special label. It's called __name__. Basically that is reserved for storing the metric name. So this is the metric name, and we pass the metric name here. We could also do something like this. We could also pass method equal to get. We could also pass instance equal to app1. So that's how we filter things here. But what I wanted to demonstrate was for this metric name, we have three distinct series. Now that we have this, we can query these distinct series, and we can get some data out of these distinct series. And that's where we get into something called instant vector. The instant vector is basically a value of a given series at a given point in time. If we don't pass time, it will give us the current most latest value. So let's look into that. So what I'm going to do is promtool query instant, pass the server name and pass the name of the metric, and we will get value for each series at a given point in time. So this is the latest timestamp, and the value for it is this 689 8, and like since we have three series, we have three different values. Instant vectors are basically useful uh, when you want to look at the value of the vector at a point in time. The query for it looks pretty much like this. And we can also look into the querying UI and see what we will see for an instant vector. So let's go to this query UI. We are gonna execute this instant vector. When we query an instant vector, you'll notice all the series that belong to that instant vector. And when we plot it, we see all the three series in the plot, and you notice that this is a counter, so it is continuously incrementing.